Hello everyone, my name is Satyam Vishwakarma and here is my term project for trimester 7. I have made a content based movie recommender system. So first we will see the demo. Here we can see it is deployed on onrender.com. So here we can see this is deployed on onrender. Let's see how it works. First we will give it some movie name. Let's say we can pick Spider-Man 3. Now it will suggest us movies based on this movie. Here we can see we have got 4 movies. Let's give input from keyboard. Let's give it Matrix, kind of a good movie. It is working, and see we have Matrix Matrix Revolutions and Helix, both related to Matrix. So now coming back to our PPT, let's see how it works. So the introduction, the objective of this project was to design and implement a recommendation engine that suggests movies similar to a user provided title using machine learning techniques. The system is based on metadata driven similarity computation and is deployed as a web application using Streamlit. What was the problem? The problem was traditional recommender system often rely on collaborative filtering, which depends on user ratings and historical interactions. However, such systems suffer from the cold start problem when user data is unavailable. Let's say we go to any portal and there we want to watch any movie, but when we want to watch any movie, we want to watch content, but in collaborative filtering we need to give some input, then only the machine will suggest us any movies or any content. If we don't give any input related to ratings or historical interactions, means if we don't give any inputs, the data will be unavailable. So in this project the goal was to develop content based recommendation system which relies only on movie metadata such as genre, cost, director, overview. Given a movie title as input, the system returns a ranked list of similar movies. I have used a dataset from TMDB 5000 movies dataset. This dataset contains metadata for approximately 5000 movies, including title, genres, cast, crew, overview, keywords. Since the dataset does not contain user ratings for this pipeline, the recommendation system process is entirely metadata driven. How is this working? The workflow of the system consists of the following steps: data loading and preprocessing, feature engineering, text vectorization using TF-IDF, similarity computation using cosine similarity, deployment using Streamlit. Each of these steps ensure that raw metadata is converted into a numerical representation suitable for similarity comparison. Let's come to data preprocessing and feature engineering. In preprocessing, missing values were handled. JSON formatted columns such as genres and cast were parsed. Top actors and directors' names were extracted. After cleaning, I combined the following features into a single textual representation for each movie, that is title, genres, top cast, director, overview. How is TF-IDF vectorization is used? To convert textual data into numerical format, I use TF-IDF vectorization. TF-IDF stands for Term Frequency Inverse Document Frequency. It assigns higher weight to words that are important in a specific movie but not common across all movies. Each movie is then represented as a high dimensional vector. Mathematically, each movie is represented as this formula where n is the vocabulary size. After vectorization, similarity between movies is computed using cosine similarity. The formula is the similarity between movie I and movie j equals the dot product of vector xi and vector xj divided by the product of the magnitude of xi and the magnitude of xj. Cosine similarity measures the angle between two vectors. If the cosine value is close to 1, the movie is highly similar. For a given input movie, similarity scores with all other movies are computed and sorted. Top case, most similar movies are returned as recommendations. What is the system implementation? The backend was implemented in Python using pandas, numpy, scikit-learn. The front end was deployed using Streamlit. The application allows the user to select a movie title, view recommended similar movies, display movie posters. The similarity matrix is pre-computed to ensure fast response time. The results were system is returning 5 to 10 similar movies per query. For example, superhero movies recommend other action-oriented films. Science fiction movies recommend thematically similar sci-fi titles. The recommendations were evaluated qualitatively through manual inspection. The system performs efficiently for the given dataset size and responds within milliseconds during local execution. In conclusion, this project demonstrates the complete pipeline of a content-based recommendation system from data preprocessing to deployment. It provides hands-on experience in text preprocessing, feature engineering, vector space modeling, similarity computation, and web deployment. This project helped strengthen my understanding of applied machine learning systems and real-world implementation challenges. Thank you.